Hi gentlemen. Today your lesson is going to focus on reviewing the chemistry units from your grade 9 and 10 science courses to prepare us for the grade 11 chemistry course moving forward. So let's go back to grade 9 and look at particle theory. If you remember, particles are the smallest individual piece of a substance. Okay, so if you think of water, if you break it down into its smallest component, you're dealing with a single water molecule. That we consider that a particle of water. Same thing with an element, something like carbon. If you broke down a diamond into its single individual piece, you're dealing with a carbon atom. And so that's the particle of your carbon or your diamond. Okay? So in terms of particle theory, there are 5 postulates, okay, that deal with particles. And the first is that all matter is made up of these extremely tiny particles. Okay? And each pure substance contains its own type of particle that's different from the particles of all other substances. It's also important to know that particles attract one another, they're always moving, and that the higher the temperatures are, the faster they're going to move. Right? So higher temperatures, more energy, more movement. Okay? And this ties into states of matter. You're going to be dealing with solids, liquids, and gases. Okay? So to start with solids, you're dealing with things with a definite shape and volume. There's still going to be a little bit of movement, but most of it's going to be vibrational. There's a lot less movement. Particles are much tighter packed together. You can see this down on the bottom right-hand side. Liquids, on the other hand, you now have a little bit less density. They have a definite volume. They tend to take the shape of their container. The particles are still fairly close together, but there's a lot more movement. Okay, and now you extrapolate that to gases, you have more energy, and now you're having more movement in terms of a gas. So now you're dealing with something with an indefinite volume. It takes the entire shape of your container, and you have particles that are far apart when you compare that to the sizes of the particles, right? So there's a lot less space between the particles, there's a lot more movement, and that's why you get this much less dense material. Okay, let's talk about physical and chemical properties. Physical properties, we're going to use both of these things, physical and chemical properties, to describe substances that we're dealing with. So physical properties, it's any property of a substance that can be observed without a change in that substance. So things like color, texture, odor, things that we can observe without changing it. These can be quantitative, so we can measure them with numbers, or qualitative, so things like just describing what we see. So a color, is it red, blue? Is it hard, soft, dense, right? And then so are these qualitative, quantitative, remembering those things. Again, quantitative comes from the word quantity, right, which implies numbers are involved, whereas qualitative comes from that word quality, where you're just describing something. Chemical properties, on the other hand, now you need to observe a chemical reaction and then describe that. So this is a little bit different than a chemical change, which we'll talk about in a second. Chemical property describes what will happen in certain situations in terms of a chemical reaction of a substance. Okay, so for example, wood is flammable. It will burn. That's its chemical property. The chemical change itself, which we'll talk about in a second, is the physical action of the wood burning, but the fact that it will burn describes its chemical properties. So physical and chemical changes, start again with physical. A physical change is any change in matter where no new substance is formed. Okay, so if you're chopping a log in half, right, you have 2 pieces of logs. They're still logs. Okay, it's still wood. There's a change in it, but it's not changing the substance into something new. Same with water. If you're boiling water, you have a liquid water, you boil it, you heat it up, it's becoming a gas. It's still water, it's just in a different form. A chemical change, on the other hand, is any change in matter in which at least one new substance is formed. So now you've got your log, you've chopped your logs, you're burning your logs, you're creating ashes, water vapor, carbon dioxide. So you're creating these new substances, and there's indicators that a chemical change have occurred. And 5 clues that indicate that are an odor is produced, you're seeing a color change, you're getting heat or light, a gas is produced, so whether that's with bubbles or smoke, you're getting that indication that there's being a gas produced, or a precipitate. So remember, a precipitate is when you combine 2 liquids and you get a solid forming. All right, let's classify matter. So now we've talked about different changes and different properties, but let's classify things. So let's start with pure substances. So these can be either classified as elements or compounds, and a pure substance is just something that contains a single type of particle. Okay, so an element contains a single type of an atom. Compounds contain two or more different types of atoms that are combined chemically into these compounds, right? And so on the bottom you can see we have water. Okay, so again, the smallest individual piece is the water molecule, but there's just water molecules present, so we consider that a pure substance. The same here on the right, we've got this piece of platinum, same idea, all of it is individual platinum atoms making that up, so it's a pure substance. Mixtures, on the other hand, now you're dealing with multiple types of particles in your sample. Okay, so we can classify these mixtures in different ways. So the first thing to do is, does it have one or two phases? Okay, so is it one consistent liquid, or are there multiple levels, different phases? Okay, so something like dirt and water, you see two phases as the dirt settles at the bottom and maybe some water along the top. Okay, and when you have something like that with two phases, you call it heterogeneous, or a mechanical mixture. You can see that on the right here. That's considered two phases. If it's one phase, we consider it homogeneous. And then we need to continue to ask more questions to really classify it further. So if you have this homogeneous mixture, can light pass through it? Okay, so if light is passing through it completely, we call it transparent or clear. Okay, and it's in that case it will usually be a solution. Now, sometimes, and you may remember this from grade 9, we also consider colloids, and so we do this test called the Tyndall test, which tests for scattering of light. And if it has a positive result for a Tyndall test, we consider it a colloid. But generally, you have this homogeneous mixture that's transparent, it's often a solution. Okay? On the other hand, if you have this homogeneous mixture and it's opaque and light cannot pass through it, it's often a suspension. Okay? It can again also be a colloid if it cannot be separated by centrifugation. We also need to review the law of conservation of mass. Okay, and the key thing to understand here is a chemical reaction is just a rearrangement of the atoms within these compounds. Okay, so as you can see here, you have your reactants, lead nitrate and potassium iodide. After a reaction happens, the products, everything that was present in the reactants is present in the products. It's just rearranged into new compounds or molecules. Okay, so the law of conservation of mass states really that nothing is created, nothing really new is created or destroyed. Things are just being rearranged. So the mass before is equal to the mass after of everything involved. So now let's talk about the periodic table. Okay, so we're dealing with three main types of elements in the periodic table. The first we're going to deal with is metals. You'll find those on the left-hand side of the periodic table, and I'll show you a visual here in a minute. But they're solid at room temperature, okay, except for mercury. They're malleable, they're ductile, they tend to conduct heat and electricity, and they're very shiny. Non-metals, you'll find them on the right-hand side of the periodic table, a much smaller section of the periodic table. But most are solids or gases, except for bromine, which is a liquid. They're dull, brittle, but they do not conduct electricity or heat in their solid form as metals do. And last but not least, we're dealing with metalloids, and that's that staircase, which you'll see again in a second. These have characteristics of both metals and nonmetals. Most are shiny, and many are conductors or semiconductors. And again, anything on that staircase that you'll see, which is the list here on the PowerPoint, are metalloids. So they have that can often have both metal and non-metal characteristics. So if you look at the periodic table, we can group it in two different ways. Groups, or the columns of the periodic table, so those vertical colors that you'll see here on the left are groups, and on the right we're dealing with periods, and these are the rows in the periodic table. Okay, and the importance here is these really define a lot of the properties of the periodic table. We're going to dig deeper into that in this unit as we prepare for the course and learn more, but it's important to understand that these groups and these periods are important in terms of classifying the properties of the different elements. Okay, so we mentioned metals, nonmetals, and metalloids. So again, you can see the majority of the periodic table is made up of metals. The blue section here are all metals. Nonmetals you find on the right-hand side, and then the metalloids, the mixture of the two you find is that staircase that kind of breaks the two metals and nonmetals up.
And then speaking of the groups, you can see we've talked alkali metals, alkaline earth metals, halogens, and noble gases, which is not spelt correctly in this diagram. But again, you can see that breakup. And again, the importance of these groups, as alkali metals often have very similar reactivity. Okay, they're all very reactive. They have one valence electron. If you remember back to speaking about valence electrons, alkaline earth metals have 2 valence electrons. So again, these metals here on the left, similar properties. They're trying to get rid of their electrons. And halogens, on the other hand, again, a group that have very similar reactivities, trying to take on an electron. And noble gases have that full stable octet, so they're happy. They're not going to make many changes. And last but not least, dealing with the periodic table, you need to be able to read the individual boxes, okay, of each element. And so the important thing here, as in this example, we have xenon. You have the atomic number often at the top. Okay, there's no decimal places involved in that because it's just the protons plus the number of protons of that atom. It can be the number of and considering that an element is a neutral atom, okay, you're dealing with the same number of protons as electrons. So xenon here, atomic number of 54, means it has 54 protons and 54 electrons. Okay, you're also seeing the atomic symbol, which is a short form for the element's name, in this case Xe. And then at the bottom you have the atomic mass. In this case you have number of protons plus the number of neutrons. And this is an average, and we'll talk a lot more about isotopes as the course progresses. But this is an average of all the protons and neutrons added up in all the different xenon atoms in the universe. Okay, thank you for your time, gentlemen.